and physical.
Come again?
Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer.
Physical layer. Okay. I asked like what is OSI reference model? I didn't ask like what are the different layers we have in OSI.
The reference model
Uh-huh.
to communicate to other devices.
Other devices. Okay.
A network. Complex before OSI model.
Okay.
iOS made this model.
How are you, Mr. Shah? What is OSI?
The OSI model is it is the middle one. So other vendor also want to connect. If we connect to the network, so other vendor first of all they don't connect it by that ISO gives this responsibility to OSI to make the reference model. So all will use it as a middle. So I have to
Middle means I didn't get that.
means first they don't connect. We want to connect to other companies or organizations. So we face the problem. So by taking the reference model, we have some facilities to be connected.
Okay. So Bharti, what are these three upper layers? Which are the three upper layers? What we studied yesterday. Did you get it? Did you get the question? Question ತಿಳಿತಾ ಏನಿತ್ತು? ओ वीडियो तो अपलोड हुआ था ना?
अपलोड मैंने देखा ही नहीं रात को।
लेट मतलब कितना?
जब मैं रात को 10 के आसपास आया
When did I upload it?
तो पर अपलोड किया था
A lot of time, right?
पर बाहर था पड़
अच्छा. Yeah, I'm asking something. What was my question? Good. Good. देखो कोई मतलब कोई लेयर मिलता है क्या?
Recorded.
Yes, Pratik. नहीं मिला क्या भाई तो? Okay. So discussing about the OSI, right? So it is a reference model. So that should be taken as a reference by all the vendors. Okay, just to design the network part. Yes, Pratik, you want something? Pratik? Okay, so in that we have 7 layers. Which are those?
presentation session layer
7th layer is what? Application layer, and then presentation, and then session, and then transport layer, network layer, data link layer, and the physical. Pratik, are you talking something? Hmm? Yeah. Okay, so in that, I mean, again, these 7 layers are again grouped into two. Okay, one is they call it as the upper layers. The first three call it as the upper layers. They are totally like internal communication. Okay, that will give the user interface to the user. Okay, and then we have bottom layers. In that we have 4 layers. Yes, so that will help us to make the end-to-end connection. Okay, and to transfer the data from source to destination with the help of some port numbers, with the help of some what do you call the IP addresses or MAC addresses. Okay, through the media. Okay, it may be wired or wireless media. Am I correct? Okay, now today we will go to the same OSI model. So I said like these are the PDUs. Okay, PDU means what? Protocol data unit. That will be the collective data at each layer. Okay. So as I said you, the application layer, presentation layer, and the session layer, all of them they are having a PDU as what? Data. And then this data will be going to the bottom layers. So that is nothing but the transport layer. So there the data will be segmented. Yes. And the segmented means what? Again, they are going to add their headers and trailers, okay, to that particular segmented data. And then that will be sending it towards the network layer. And there the PDU is called as what? This segments become their packet, okay, by adding some headers and trailers of this network layer. Okay, and that packet goes to the data link layer. Yes, again the data link layer is going to add its own header and trailer. Okay, and at that time that is called as what? Frame. And then that will be converted into bits in the physical layer, because we can't send exact numbers or alphabets towards the destination. That should be converted into bits. Bits means what? Zeros or ones. Okay, and those zeros and ones again converted into electrical or what do you call light signal or a wireless. Okay, radio frequency or anything like that. Okay, then they are going to reach the destination. Okay, let me tell you how exactly the data goes there. So this will be my sender end. Okay, and this will be my receiver end. After that, the 7 layers we have. Seventh layer is what? Application layer. And then we have presentation layer. Session. Okay, and then transport layer. After that, we have network layer. And then we have data link layer. And then we have physical layer. And obviously, the receiver end also will be having the same. Yes. So application. And then we have presentation. Session. Okay, and then transport. After that, network. And then we have data link. At the end, we have physical. Okay, now let's suppose like we have, some of the protocols which works at this, some of the events which works at this application layer. Just take your email. Okay, just take the email and that will be generated at the application layer. Yes. So let's suppose like we have an email. Yes. And how that should be presented. Okay. So that will be defined at this presentation layer. Okay. And for that email, okay, whenever you open that email system, yes. So that at that time, the session will be opened for that email. Okay. And it is going to keep every data of this email separately, not mixing with any other application. Okay. So this we can call it as a all data. The email that I can say. Okay. Unless I hope you remember that at presentation layer, only it is not going to only present the data as required by the user. Okay. Other than this, what it do? Presentation layer. It will encrypt the data, compress the data, and encode the data at sender end. Okay. Let's suppose like this data is encrypted. Okay. And compressed and then encoded. Understood? Now, this data goes to the transport layer. Okay. So let's suppose the data as data only. Okay. Data as data only, just for example. Yes. So once this data goes to the transport layer, what the transport layer will do? It will just break this whole data into some multiple segments. Okay. What it does? It is going to make this kind of segments. This is one segment. This is segment, second segment, third, and fourth. Like this. Okay. And it will take the first segment and it will add its own header and trailer. Okay. Let's take the first segment. Okay. And let's add the header for that one. Header will be like source port number and the destination port number. Don't worry, this port number we are going to learn when we are learning the TCP. Okay. And after that, it will be giving the checksum value. Okay. And this collectively called as what? A segment. This is what? This is a port number. Okay. This is called as what? It is segment. Okay. What is the PD of that transport layer? What is the PD of transport layer? Segment only, right? Yes. So this is called as what? Segment. When this segment goes to the network layer, only this segment I can say. Not that I have not gone for this ATE. I'm still with the D only. Okay. So this particular segmentation and segmentation of the data, every segments we are going to go through this header and trailer. Okay. And this segment, as I said you, it will go to the network layer. Okay. What does the network layer will do? It will take that segment. So I'm going to take it as a segment only. So in that segment, everything will be there, like source, destination, port number, the data, and the checksum value of the transport layer. Okay. And after that, on top of that, it is going to add the header and trailer of this network layer. Okay. What will be there in the header and trailer? Here also, the source and destination IP addresses will be there. Because you already know that network layer deals with IP addresses. Okay. And again, here the checksum value. Okay. I'll tell you why this checksum value is really important. Okay. And this is called as what? What's the PD of the network layer? It's a packet. Okay. Inside this packet, there's a segment. Inside that segment, the upper layer data is there. Upper layer data means what? Application layer data, presentation layer data, and the session layer data. Okay. This is how it is going to encrypt all the data inside those packets, inside those headers. Okay. At each and every layer. Okay. Now, when this packet goes to the data link layer, what it does again? It is going to add its own header and trailer. Okay. So in that case, the packet goes here. Okay. On top of that, it is going to add a header and trailer. Okay, here again it will be like source and destination, but this time it says a MAC address. Exactly, it is a MAC address, and this collectively is called as what? Frame. Okay, when this frame goes to the physical layer, what it does? Obviously, it is going to convert it into bits. Okay, so there it is called as what? Bits. Yes, now this bits, what they will do? They will go through some channel. It may be a wired channel or it may be wireless channel. If it is a wired channel, if it is a twisted pair cable, then the signal will be in the electrical signal. Okay, data will be in the form of electrical signal. If it is a optical fiber, then it will be in the light signal. If they are using wireless, then it will be in the radio signals. Okay, then obviously it will go towards the destination. Okay, then what happens in the destination? The physical layer will take the data. It may be in the any form, electrical, light, or radio wave. Okay, and it is going to rebuild it. If it is like electrical signal or a light signal or a radio signal, it is going to convert it into bits. Okay, so those signals will be converted into bits here. So after converting those bits, okay, so they will be forwarded towards the data link layer. Okay, what the data link layer will do? It will open this particular frame. What is there in the frame? Inside there is a packet only, but it is not going to touch the packet. It is only going to check what? The destination MAC address. Source MAC address and the destination MAC address. Okay, majorly concentrate on destination MAC address. Why? Because it will check for what? Is this packet or a frame for me or not? By checking or comparing its own MAC address to that particular destination MAC address. What it is there in the frame. Okay, if it is matching, okay, so you can see here when this frame goes to the data link layer, it only open that frame. It only going to check the destination MAC address, and even it will check the checksum value. If both are getting matched, then it is going to forward that remaining packet towards the network. Okay, what the network will do? It is going to check this one. That means it is only going to check the IP address. Okay, if the destination IP address is matching, then it is going to receive that packet. Otherwise, it is going to drop the packet. Understood? So again, let's suppose like both IP address and checksum values are getting matched, then it is going to send it towards the transport layer. What the transport layer will do? It will open that segment. Okay, based on, once it open that segment, it is going to check which protocol it is using. If it is a TCP protocol, then it is going to send the acknowledgement if it is properly received. Okay, if it is using UDP, then it is not going to send any kind of acknowledgement. Yes, we are going to learn it later. What is this TCP? What is the UDP? Okay, and after that, which protocol inside that? Okay, it is going to check the TCP header. Okay, whatever the source header I said, whatever the header I said, that it should be like the TCP header, either TCP header or the UDP header. Okay, if it is a TCP header, then it is going to check that which protocol it is using. Okay, like it is using the email. Okay, for that it is going to generate the session. Okay, so that will be forwarded towards the session layer. Okay, session layer is going to open one session for that email. Okay, and then session layer will forwarding that packet towards a presentation. What the presentation layer will do? It will check that this particular data what I got from the source end, it got encrypted, it got compressed, and it got encoded. Then I have to do it ulta. What do you mean by ulta? I have to decrypt it, decompress it, and decode it. So everything will be done at the presentation layer, and it will try to understand like how to present this data to the user. Okay, so whether it is in the form of text, whether it is in the form of image, okay, whether it is a video, whether it is a voice, so everything. So that will be decided at the presentation layer, and then that will be forwarded towards the application layer. There the user is sitting like me, okay? He will be watching all these things. Okay, so this happens for each and every segment. Understood? Clear, everyone? So how the data packet goes from sender end to receiver end, and how it exactly rebuilds the data. Clear? Any doubt? Okay. So don't forget the PDUs, what I said. The upper three layers having the PDU as data, okay? And then the transport is having segment, and then network is having packets, and then data link is having frames, and then the physical is having bits. Clear? Great. Yes, online? Any question?
If the content is a very large content or everything has a size, right? Here, when you say from left side, when it is traveling to the right side to the receiver, there should be some kind of size, right? Data size. So there should be something which is going to say that, okay, this is a continuation data, this is a new data, etc. So how does it understands that, okay, this is a continuation data which is coming?
See, we will be having, as I said, right, every data, sorry, the layer is going to add its own header.
Correct.
So later we are going to study those headers. So in that we can see like how it is going to recognize what kind of data it is, a new data or a previous data.
Right, right. Okay, okay. Okay, sure. Thank you.
So next, the first layer, that is a application layer. Okay, as I already said you, this is a user interface. Okay, you can see here, this is where the users actually communicate with the computer. Basically, it is the interface between the actual application program and next layer down by providing a way for application to send information down through the protocol stack. Okay, this is where the user will be sitting and he's trying to talk with the system. He's trying to talk with the computer. Okay, if I'm talking with my computer, this is all because of the application layer that is allowing me to talk with or communicate with my system. Okay, behind that, there are a lot of layers again. Okay, if I'm able to talk with Mr. Pradesh or someone, okay, so it is all because of the bottom four layers. They are making me to communicate with the online people. Okay, and the same application layer is going to provide this data, okay, towards the next bottom layers. Okay, just like the presentation layer, session layer, and the bottom layers. Yes, so it's a way for application to send the information down through the protocol stack, and it also identifies and confirm the communication partner availability with the required resources. Then these are the some different events which takes place at this, what do you call, application layer, just like file transfer, email, enabling remote access or network management activities or client server resources. Okay. So if somebody asks like, what is the application layer? You can just say that this is a user interface that will allow us to communicate with the computer. Okay, that's it. That will be enough. Next is presentation layer. So presentation, the layer gets its name from its purpose. What's its name? Presentation. That means it presents the data to the application layer in the required format. Required format means what? Again, it may be any format, the text format or image format or a video format or audio format, whatever it format it may be. Okay, that is a responsibility of that presentation layer, just to present it to the user via that application layer. Okay, so it is responsible for data translation and code formatting. Okay, so that's the reason it is called as what? Translator layer of the OSI model. They may ask like, which is the translator layer of the OSI model? Okay, which is a translator layer? Presentation layer is a translator layer because it will allow us to data translation. Okay, whatever the data format we want, so that will be presented by this presentation layer, and even code formatting will also be there. Okay. which provides the coding and conversion services. It ensures a successful data conversion into the standard format before transmission. Okay, before transmitted towards a destination, and it is going to ensure that yes, whatever the data which is required of the destination, it should be converted in a required format. Okay, for example, you can see here, it translate, just an example, translate EBCDIC. These are the codes that will be understood by this computer. EBCDIC is nothing but what? Extended binary coded decimal interchange code. And I mean, to this kind of data to other ASCII. Okay, what is this ASCII? American Standard Code for Information Interchange. So this kind of conversion will be taking place in the presentation layer. Okay. So, and some other key functions, as I already said you, key functions like what? Data compression, decompression, encryption, decryption, encoding, and decoding are also associated with this layer. Okay. Understood? So this is what the presentation layer. Next, we have session layer. So what is this session layer? This layer is responsible for setting up, managing, and dismantling the sessions between presentation layer entities and keeping the user data separate. And it also controls a dialogue between the devices. Okay. So I'll give you a small funny example. Okay. Okay. We have Nikhil, right? Yeah. So he's Nikhil. Okay. So Nikhil is having at least 4 girlfriends. Yeah. Okay. We'll take 4 now. Okay. I don't know how many you have. Okay. I don't know their names also. So I'm going to take it as A, B, C, D. If you remember their name, you can tell here. Okay, it's okay. I'm just kidding. Okay. So their name is like A, B, C, D. And what he's doing, he's talking with them at the same time, with everyone on different application. Okay. Just like WhatsApp. Okay. And then Instagram. And then Facebook. And then Snapchat. Sorry. Phone pay. You do that? Okay, he's talking with them at the same time on these different applications. Okay, and when he says hi to first girlfriend called A on WhatsApp, what the session layer will do? Whenever this application opens, WhatsApp opens, it is going to open a session for that. Okay, at the same time, he will be opening all these applications. Yes. So he'll be on Instagram also talking with B. He'll be on Facebook also with talking with C, and he'll be on Snapchat talking with D. Okay. When he say hi to this particular girlfriend A, okay, the session will be created, and whatever the data it is getting generated at this, I mean during this communication, that will be kept separate. Okay. Some personal things will be he'll be talking with girlfriend A. Okay. What if that personal thing will go to girlfriend B? What may happen? What may happen? World War III? Yes. So that's the reason what the session layer will do. It is going to keep this data separately for each application. Okay. It is not going to mix this WhatsApp data to this application. Sorry, the Instagram. Okay. This Instagram data with the Facebook and Facebook data with the Snapchat. It is not going to do that. It is going to keep this data separately by keeping this dialogue separate. Okay. This is what the session layer in simple words. In your words, I can say. Okay. I hope you got it. Yes. Yes, Nikhil. What it does? It is responsible for what? Setting up, managing, and dismantling the sessions. Once he said hi to the first girlfriend on WhatsApp, okay, so till then to bye. Okay, whatever the data, whatever the time he's taking, okay, so that will be set it up and then manage until he say bye. Okay, once he say bye and close that WhatsApp, Till then, the session will be there. Understood? And whatever the data will be created during that duration, that will be kept separate. Yeah, that's what the use of this session layer. Okay, and please don't explain the same in interview. Okay. Next is transport layer. Okay, this is also called as what? Heart of the, not nickel, OSI. Okay, this is called as what? Heart of OSI, because this is where the end-to-end communication will be established. Yes. So transport layer, this layer segments and reassembles the data into single stream. It will combine all the data which received from upper layers into concise data stream. So what it is, as I already said you, transport layer will do the segmentation at the sender layer level. Okay, what it does? Segment means what? Breaking the whole data into some multiple parts and adding the headers and trailer to that one. Okay, once it reaches the receiver end, obviously it has to reassemble it, right? So that is the work of this transport layer. What it does, it is going to segment the data and reassemble the data into a single stream. Yes, it will be combining all the data which is received from the upper layers into a concise data stream. And these protocols provide end-to-end data transport services and establish a logical connection between the sender and the receiver on a inter-network. So this is where the two well-known protocol works. The first one is a TCP and the second one is a UDP. With the help of these two protocols, it is going to establish the connection between the source and the destination, or sender and receiver, I can say. Okay, first it will say like, if I want to talk with Dinesh, okay, so for initially what we have done on the first day, what we have done? We've done the introduction, right? So here also in transport layer, they'll take the introduction. Okay, hi, I'm Arun. Okay, are you able to talk with me? If he says like, yes, I'm comfortable to talk with me, then only the communication builds. If he's not, then no. Okay, so this is what happens in the transport layer. Okay, with the help of these two protocols. One is what? TCP, Transmission Control Protocol, and second is the UDP, User Datagram Protocol. Okay, where TCP is known as a reliable and connection-oriented protocol, and UDP is not a reliable. This is unreliable and connectionless protocol. Okay, and it also performs error correction before retransmission. I think I said you, right? It does the error correction and detection will be done by data link layer. Okay, now we'll see the first one, TCP, Transmission Control Protocol. It is a connection-oriented protocol that allows communication between two or more computers by establishing connection in the same or different network. So what it does, here a famous process works, that is a three-way handshake process. Okay, so before sending the actual data, what it does, first it asks like, are you available to talk to the destination device? Okay, if the destination device acknowledge back, yes, I'm available and we are comfortable to talk, then only the actual data will be transferred towards the destination. Okay, so that's the reason it is called as what? Connection oriented protocol. Okay, and for every data, for every segment, it is going to ask for the acknowledgement. What do you mean by acknowledgement? Did you get the data or not? If the destination says, yes, I got your data, whatever you are sent, okay, then again it is going to send the next segment. Till then, it will not. Okay, so that's the reason it is called as what? Reliable protocol. Understood what is the connection oriented and reliable? Connection oriented means what? first it will establish a connection and then it will send the actual data. And once it start to send the actual data, it will ask for acknowledgement for each and every segment. Okay. So it is the most important protocol that uses a internet protocol, that is IP, to transfer the data from one computer to another computer. And sometimes it is also called as what? TCP IP. Okay, where it's going to ensure that the connection is established and maintained until the data packet is transferring between the sender and receiver is totally complete. Until the data transmission is completed, okay, so it's going to maintain the same connection what it established initially, but it's not happening in the UDP. UDP is totally different as compared to the TCP. Okay, so any question in this transport layer and the TCP? Sure. Next we have UDP. So it is a connectionless protocol that allows communication between two or more computers. Yeah, it is a connectionless protocol that allows communication between two or more computers without establishing any connection. So what you are saying in the TCP, first it will establish a connection, okay, and then it will send the actual data. But in UDP, based on the destination address, if it is having the destination IP address, based on that it is going to send the data. It is not going to think like whatever the data I'm sending, it's going to reach to the destination or not. Okay, what is my duty? My duty is to send the data. I'm not going to think of like whether it is going to reach the destination. If it is reaching, whether it is reaching in the proper format or not. No, I'm not going to think that. Okay, that's what happened in the UDP. So that's the reason it is called as what? Unreliable protocol. Okay. So in this protocol, sender sends the data packet to the receiver that holds the destination IP address. And UDP does not ensure to deliver the data packet to the correct destination, and it doesn't generate any kind of acknowledgement about the sender data. Similarly, it does not acknowledge the receiver about the data, hence it is an unreliable protocol. So there is no any concept of acknowledgement in the UDP. What you have seen in the TCP? In the TCP, it seeks for acknowledgement for each and every segment what it is sending from source to destination. But in this UDP, it doesn't even bother about any kind of acknowledgement. Yes, I'm sending the data, it is your headache. Whether you are reaching, whether the data is reaching, okay, I don't know. Yes, but I'm sending it, that's it. Okay, that's the reason it's called as what? Unreliable protocol. Clear? So you can find this kind of communication in TV, this one, what do you call? Broadcasting, radio broadcasting. Okay, they're not going to think like if a TV is broadcasting something or radio broadcasting something, they're not going to think like whether my data, what I'm sending, whether it is reaching the users or not. Do they going to think? No. Okay, they don't even ask, are you having an issue to get this data? No. Okay, so that's kind of a example of this UDP. Okay, so difference between TCP and UDP. So this TCP already know that it's a connection oriented protocol and it's a reliable protocol. Wherein user datagram protocol, it is a connectionless protocol and it's a totally unreliable. And these are really important. The protocol number of this TCP is a 6 and UDP is a 17. Okay, and this TCP is a slower process. Why? Because of that three-way handshake process. Okay, that we don't have in UDP. So that's the reason it's a faster process. Yes, and the header size of this TCP is what? 20 byte. Okay, it may go up to 60 byte. Okay, why I'll explain it later. Okay, if they ask you like what is the TCP header size, you may say it like 20 bytes also, and you may say it like 20 to 60 bytes. Okay, both are okay. And then UDP header size is what? 8 bytes. Okay, both header we are going to discuss after this. Next, the TCP, it's going to retransmit the data if it is required. Again, here the acknowledgement will be in use. If it is not getting any acknowledgement for that particular segment, then it is going to retransmit the data. If it is getting any acknowledgement from the destination, it is not going to send any kind of data again. Okay. And in UDP, retransmission of the packet is totally not possible because we can't find any kind of acknowledgement in the UDP. Okay. And these are the some different TCP protocols. HTTP, HTTPS, Telnet, SMTP, etc. Okay. And then UDP, it used by this DHCP, RIP, SNMP, etc. RIP is not a rest in peace. Okay. We are having a separate protocol. Yes. Yeah, now we'll see the three-way handshake process. Okay, connection-oriented communication. Okay, connection-oriented communication. For reliable transmission of the data, the device must first establish a connection-oriented communication. And this system is known as what? Call setup or three-way handshake process. Okay, this happens only in the transmission control protocol, not in the UDP. Okay, so what happens here? For reliable transmission of the data, it is going to first establish the connection between the source and destination, and then it is going to transfer the data. Okay, and this process is called as what? Call setup or three-way handshake process. And once this process is completed, I mean the transfer of the data occurs, then a finish call, when a finish call termination takes place to tear down the virtual circuit. And this is called as what? Four-way handshake process. Whatever the call termination takes place, that is called as what? Four-way handshake process. Three-way is what? Three-way is for established a connection, and four-way is for terminating the connection. Okay. That first one, I'll show you practically later. So three-way handshake process or a call setup process. So you can read it later. In simple words, I'll tell you. So let's suppose like this client wants to talk with the server. Okay. And both are using the TCP protocol. Then what they will do, the client will say like, hey, hi server, I just want to have some word with you. Okay. I just want to fetch some data from you. Okay. So what the server say, if the server is available, if it is ready to make the communication with this client, okay, then it will say like, yes. Okay. Yes, we are, good to go for the communication. Yes, I'm able to send any kind of data, whatever you want. Okay. And then again, what the client will do? Okay, thank you for that. So these are the three handshakes. What happens? First, saying hi to the server, and again the server say hi back to the client. Okay, and this client will say thank you for that. So these are the three. Okay, but in this three-way handshake process, this they call it as a something different. First handshake is what? Synchronization. Okay, this is my client. Okay, and this is my server. I said right, some three packets will be exchanged between these two. The first packet is what? Synchronization. Okay, we call it as a SYN packet. SYN. SYN means what? Synchronization. This is the first handshake, I can say. First handshake that will be sending some data like, synchronization. So during this, it is going to be sending the SYN packet. Okay, so we have some flags here in TCP. Okay, once we study that header, okay, we are going to learn what are those headers, sorry, flags. So SYN packet will be high. Next, it is going to send the acknowledgement. So in this time, the acknowledgement will be low because this is a first packet which is going from client to server. After that, it will be sending some sequence number. So that will also be 0 initially because that's a first packet from client to server. Okay. Once that synchronization request goes and reach the server, if it is okay with that synchronization, then it is going to send the SYN-ACK pack. What is that? SYN-ACK. What do you mean by SYN-ACK? Synchronize and acknowledge. So that will be the second handshake. What is that? Synchronization, acknowledgement. Okay, in this case, the flags will be like synchronization will be high. Okay, and acknowledgements also be high, and sequence number will be low because this is also the first packet from server to client. Okay, this is the second handshake, and the third handshake that will go from client to server again as what? ACK. First packet is SYN, second packet is what? SYN-ACK. Okay, and the last packet is ACK. Okay, once this synchronization acknowledgement which will get from the server, then again the third handshake takes place. Third handshake, that is acknowledge. Acknowledge from client to server. Okay, so in that case, the synchronization packet will be low because already synchronization already happened. So why to send the same packet again? And then acknowledgement will be high and the synchronization will be 1 at this time because this is a second packet from client to destination. Sorry, client to server. Understood? So this is called as what? Three-way handshake process. Okay. After this, the actual connection will be established. Then they can exchange the data between this client and server. Clear? Understood about what is three-way handshake process? Understood what are the different flags we have in each and every flag? This one, handshake. We have synchronization. We have acknowledgement. Okay, and the sequence number that is different. We are going to study in the TCP header. Don't worry. Okay. Any doubt here? Yes. Online, any doubt?
No, sir, no, I'm okay.
Okay, the same thing you can read here if you want. The first connection agreement segment is request for synchronization. That's nothing but the SYN packet. Okay. The next segment is what? Acknowledgement. Okay. The request and the established connection parameter between the host. Okay. They are going to check the parameter between these two. Okay. After synchronization. And this segment requests that the receiver sequencing is synchronized and here as well, so that the bidirectional connection can be formed. The final segment is again acknowledgement, okay, which notifies the destination host that the connection agreement is accepted and the actual connection has established. So the data transfer can now begin. Okay, first they will send the synchronization request. Okay, for that synchronization request, the server is going to acknowledge that to the client. And for that acknowledgement, again, the client is going to acknowledge to the server, and then the connection will be established. Clear? This is a three-way handshake process. And once the data transmission is done, then the four-way handshake process will take place. Okay. So four-way handshakes is nothing but what? Here some of the flags will be there, like finish flag. Okay. So client is going to generate the finish flag. Okay, I just want done with the data transmission. Okay, so I'm ready for this call termination. Again, for that call termination request, the server is going to acknowledge that towards the client. And again, server is going to generate one more call termination just to finish that established connection. Again, that will be reaching the client, and then again it will be sending the acknowledgement. So these are the four handshakes. Finish, acknowledge, finish, acknowledge. Okay. So next is connectionless service. So it is used in a network to transfer the data from one end to another without creating any connection. So it does not require establish a connection before sending the data from sender to receiver. So what it does in connectionless service, as already said you, this is used by which protocol? UDP protocol. Okay, it is not going to establish any kind of what do you call connection before sending the data. Okay, so it is an unreliable network service because it does not guarantee the transfer of the data packet to the receiver, and data packet can be received in any way. This is called as what? Connectionless service. Yes, so this is all happening in the transport layer. Till now we were talking only about transport layer. Understood? Next we have network layer. So it manages device addressing, tracks the location of the device on the network, and determines the best path to move the data. As I already said you, network layer deals with IP addresses. It is also called as what? Logical address. It is also called as what? Logical address. And that will be given to each and every device in the network just to locate where exactly that device in the network is. Okay. And the same logical addresses are used to get the best path to reach the destination by this router. I hope you already know that. Some two devices works at this network layer. What are those? Two devices which works at this network layer. It is their router and a layer 3 switch. Not only switch, it is a layer 3 switch. Okay, which works at this layer, and it works based on the only IP addresses. Okay, This was about the network layer. Next is data link layer. It provides the physical transmission of the data and handles the error notification or detection. I said you before what it does. It will send the data based on physical address. What do you mean by physical address? It's a MAC address. And apart from that, it is going to handle the error detection and notification. Okay, so it is going to detect the error, okay, while transmitting the data. If it find any error, then it is going to be notified to the transport layer. Okay, and even also it will control the flow. It means like this layer will ensure the message are delivered to the proper destination on LAN using the hardware address, just like the MAC address. Okay, and it will translate the message from network layer into bits for physical layer to transmit. What it does, here it will be having the frames, and those frames will be converted into bits. Okay, and the same bits will be carried by this physical layer. Okay, and at this layer, which are the different devices works? Which devices works at this layer 2? Layer 2 switch. Layer 2 switch and bridge. Okay, with the help of what? MAC address. Okay, next is what? Physical layer. So this layer does two things. What is that? It will send the bits and receives the bits. That's it. Okay, so it sends the bits and receives the bit, and will be in the form of what? 0 and 1s. At this layer, data will be forwarded from one device to another device in the form of what? Binary bits with the help of some various communication media. It may be wired or wireless. These two, with the help of these two media, we are going to send the data. Okay, and at this layer, two devices works. One is a hub and second is a repeater. Okay, so this was about the OSI reference model. Any question? Sure. Yes. Next, we are having one more model. Okay, I'm not going to go very deep in that TCP model because it works similar to this OSI model. Okay, but the thing is, like, as I already said you, this OSI model is called as what? Reference model. Okay, and this TCP IP is called as what? Practical model. Okay, reference model and practical model. Yes, but almost we use TCP IP model. In every network, we use only TCP IP. Okay, this is just taken as a reference. Why? Because how many layers you can see in the TCP IP model? Only 4 layers. So when the data has to, traverse this 7 layers in the OSI reference model, it will take some longer time. So that's the reason we call this TCP IP model as a practical model, where the data has to go through only 4 layers. What are those layers? Application layer, transport layer, internet layer, and the link or network interface layer. Okay, where you can see here this 3 layers, the upper 3 layers like application layer, presentation layer, and the session layer, they will be merged into only one layer in the TCP IP. And here also we call it as a application layer only. And they kept this transport layer as it is, as a transport, and they call this network layer as what? Internet layer in the TCP. And these last 2 layers, like data link layer and the physical layer, they're again merged into one. And they call it as a link or network interface layer. Okay, so everything will be same. Application layer will be handling the process of giving the user interface and presenting the data and maintaining the session. Okay, here it was taken care by different layers, but here it is taken care by only one layer. Okay, and transport layer again It's going to establish a connection based on that TCP or UDP, and then internet, it is going to give the best path based on that IP address, and this link or a network interface where it will be handling both. Handling both means what? Frames and bits. Okay, here it is going to use the MAC address to reach the destination within the same network. Yes, and it is going to convert those frames into bits just to reach the destination. Okay, so this is what the TCP IP model. Clear? Next we have TCP and UDP header. Before that, I just wanted to show you something. Okay, I'm going to show you a simple, like, what are the different flags what you're seeing in the, they call, three-way handshake process. Okay, so I'm going to capture the packets between this PC and the router. Okay, so I'm going to take the telnet of this one router. Okay, before that, I have to configure these devices. So let me do that. Don't think much what I'm doing and all. You can understand later. Okay. Okay. You can see here some of the packets are getting exchanged between these two now. Okay. So till not a lot of that. So let's take the remote of that one. Okay. Let's take the remote of that router. Okay. By saying telnet 10.1.1.1. Okay. Don't worry. You can understand it later what exactly I'm doing. So once I said, given this password, immediately I hope you're seen behind. It got exchanged lot of packets. Okay. Now, so once I said like telnet 10.1.1.1. Okay. So once I said telnet 10.1.1.1, immediately they exchange some initial 3 packets. What are these 3 packets? TCP. After then only they exchange the telnet packet. Okay, but I said telnet the router first. But what it has done? First is exchange the TCP packets. That means what? It tries to establish the connection first and then it sent the actual data. Okay, let's see what we have in this TCP. Okay, you can see here, this is the time and this is the number of that packet. So the packet 10, 11 and 12. So these are R3 TCP packets. Okay, so at what time they sent 35 second, 65 millisecond. Okay, so from where it is going from 10.1.1.2, that's nothing but our PC device. Okay, where it is going to, source is what? 10.1.1.2 and destination is what? 10.1.1.1. That's nothing but the router. Okay, so what protocol it is using? It is using the TCP protocol. That's nothing but transmission control protocol, where it will be exchanging some SYN packet. Sequence number is 0. Okay, so let's open that packet. You can see it easily. There it goes. So we have some 4 layers here. First one is what? The frame. That's nothing but the physical layer. Okay, second one is what? Ethernet means what? It's a data link layer. And third one is what? Internet protocol. That means a network layer. And transmission control protocol. That means what? Transport layer. Okay, now we are only seeing this 4th layer. Okay, you can see here what it is doing. It is having a source port number. I think if you remember when I was talking about the data flow from sender to receiver, I said like it will be attaching some source port number and the destination port number. Same thing you can see here. Source port number, that will be having some random number between 0 and 65,535. Okay, that we'll see later. Source port number, that is having 11,004. Okay, and destination port number is what? It is 23. 23 is the protocol number of that telnet what I'm using. I'm using the telnet process, right? Telnet tool. Okay, just to take that remote access of that router. Okay, that is having the protocol number as a 23. Okay, that's the reason the destination port number will be 23. After that, sequence number is 0 and the length. You just forget about the length. Okay. You can see here sequence number is 0. Next, I'm going to open the flags. There it goes. Yeah, these are some different flag we have. Okay, actually we have some 6 flag in the TCP header. Okay, what are those 6 flags? First one is a synchronization. Second one is a acknowledgement. Next one is a finish. Okay, next we have reset. Okay, after that we have urgent flag. Okay, and one more we have, that is, what was that? Yeah, acknowledgement, synchronize, finish, push. Okay, last one is also what? It's a push flag. These are the 6 flag we have. Okay, you can see the same thing here. One is the urgent flag, second is the acknowledgement flag, next is push flag, reset flag, synchronization flag, and the finish flag. Okay, which flag is high here? Only synchronization flag is high. Okay, only that is set, and all are not set. That means now this is a first handshake which is going from PC to the router, just trying to synchronize the communication. Okay, so that's the reason you can only see the synchronization flag is high. You can see remaining all are 0 only. Okay, this is a first flag, sorry, first TCP packet. After that, if you go for the second one, where is the second one? The 11th one. Okay, in here, what you can see? Now the source port number got changed because which is coming from 10.1.1.1. This is nothing but what? Router. Router is replying back to the PC now. Okay, what is the PC's IP address? 10.1.1.2. Okay, that's the reason the source port number is 23, because in the previous packet only they have given as a source port number was 11,004. Okay, and destination was 23. Okay, now the router is replying back to the client, I mean the PC device. So that's the reason the same destination port number whatever given in the previous, now in this case it will become the source port number. Okay, that is 23, and the destination port number is what? 11,004. Okay, and still the sequence number is 0 and acknowledgement was 1. Okay, you can see here this sequence number is 0, and then the flags. How many flags are high here? Only 2 flags are high. One is synchronization and second is the acknowledgement. Synchronization flag is high and the acknowledgement flag is also high. That means which is coming from router to PC. Yes, I am able to give it the remote connection. Okay, once this reaches the PC device, PC is going to again generate one more third packet. Okay, you can see here where it is coming from. It is coming from 10.1.1.2. That is nothing but the PC device. Where it is going towards? Router. That is 10.1.1.1. Okay, which flags are high? Only acknowledgement flag is high. Okay, and sequence number is 1, because this is a second packet which is going from PC to router. Okay, and let me tell you, in this one we start everything with a 0, not with 1. We start everything with a 0. That's the reason the first sequence number was 0, and now it is giving it as a 1. Okay, so you can see here, any other flags are high? No, only acknowledgement flag is high. At this time, the source port number is again the same, because which is going from PC towards the router. Okay, and the destination port number is what? 23. Okay, here the sequence number is 1 and acknowledgement number is also 1. Other than this, you can't see anything in the flags. Okay, and remember this also, reserved bits. Okay, once we discuss about the reserve bits, you can understand. Yes, reserve, actually the reserve bits are 6 bits. 6 bits of reserve bits we have. Okay, but currently remaining how many? Only 3. 3 are already used for accurate ECN and congestion window reduced and echo. These are 3 already used for what? Whatever the reserved we kept for the future use, we already used some 3 of it, and still we are remaining with only 3. Okay, after this, I talked one more thing, that is a 4-way handshake process. Okay, we'll end this session what we have created between this switch and this PC and the router. Okay, by saying exit. Okay, now we can see once I say exit, some 4 packets got exchanged between these two. Okay, I'll just stop the capturing here. You can see here. Till now, the telnet information was getting exchanged between the devices. But now, once I said exit, immediately 4 packets got generated. All 4 packets of TCP. Okay, which flags are high here? Finish flag, push flag, and the acknowledgement flag. So let's open those flags like 219, 220, 221, and 222. So these are the 4 packets that we have. First, we'll open the first packet. Okay, so where it is going from? Router to PC. 10.1.1.2, 10.1.1.2. 2. Okay. So let's open this one. You can see here. Again, they will be using the same port numbers because they were in the same connection. Okay. So source port number, that is 23 because which is coming from the router, and destination is what? 11,004. This time the sequence number is something random. Random means what? Again, now whatever the based on what port number they were using. Okay, 104. And acknowledgement number is what? 53. Okay, forget about that. Next, come to this one, the flags. I push the message. I pushed a message. What is that? Exit. Okay, so that's the reason this push flag is high. So this will say you that the administrator, okay, just try to terminate this established connection. So that's the reason I'm enabling this push flag. Okay, after that push flag, what you can see, the finish of that call established connection will be finished by enabling the finish flag. Okay, at the same time, it is going to acknowledge to the PC, yes, I'm ready to terminate this connection. Understood? And once this reaches the PC, once it reaches the PC, you can see here, at that time, only acknowledgement will be high. You can see here from where it is coming. Source is 10.1.1.2. That's nothing but the PC. 1.1 is nothing but the router where it is destined to. Okay. After that, source port number 11,004 and the destination port number is 23. That means going from PC to router. Okay. And here you can able to see only one flag is high. Acknowledgement. That means the PC is ready to terminate the call here. And after this, the PC is again going to be generating one more call termination by its end, from its end. Okay. And those two are like this. The 221 packet, what you can see, that's the same. Here also you can see the 3 flags. Okay. One is push flag, second is the finish flag, and the acknowledge flag. I'm ready to finish this established connection. Okay. So close this one. And for that, again, the router is going to be replying back with a acknowledgement. Only acknowledgement flag is high here. Clear? Am I clear? Yeah. Sure? Okay. So this was about the different flags what I was talking in the 3-way handshake process and the 4-way handshake process. Yeah. Online? Any doubt? Mr. Bosu, Pradesh?
I think I have to rewatch it. A few things. I think I'll rewatch it and try to.
Yeah, if I'm going too fast, then please let me know, okay?
Yeah, sure.
Yeah. Pratik, Vaishnav, what do you think? Okay. Okay, next we have TCP header and UDP header. Okay, so what was the size I said of this TCP header and UDP header, if you remember? 22, 60 bytes of UDP header, right? TCP header. And UDP header is having 8 bytes. Okay, so let's see how it is 20 bytes. Okay, so these are some different fields we have in the TCP segment header. Okay, the first field is like source port number. Second field is like destination port number. Each having the size of what? 16 bits. Okay, total it makes like 32 bits. Okay, next we have sequence number. The whole sequence number is having the size of 32 bits, total 32. Next we have acknowledgement, that is also having the size of 32 bit, 32. Okay. Next we have data offset, that is nothing but the header length of this particular TCP header. Okay, that is of 4 bits. Next we have reserve bits. How many bits I said? Reserved. 6 bits. And flags. How many? How many flags we had? Huh? 6 flags, right? So 6. And window size is what? Again 16 bit. Total it is making like 32 again. Next we have header and data checksum value, that is of 16 bit. Urgent pointer, that is of again 16 bit. Total 32. Okay. If your mathematics is really good, please add it immediately. Fast. One 160. Okay. And 8 bits is equals to 8 bits is equals to how many bytes? 8 bits is equals to how many bytes? 20. Huh?
1 byte, right?
1 byte. It's 1 byte, guys. Where is what? 120. Okay, I just want to convert this into byte. Okay, so that is divided by 8. Okay, that will make you 20 bytes. I think this is what I said. Yes. When it comes to option, okay, it may go up to 60 byte. That's the maximum range we have given for this option. I'll tell you what exactly this option is. Okay. Now let's go in detail with this TCP header. So first field was like source port number and the destination port number. Okay. So size of that is 16 bit. Each field of that port number are like 16 bits. So that will give you total 2 raised to 16 is nothing but 65,536. Okay, so total 65,536 port number will be having. Whatever the random number you are seeing when I was shown in the packet. Okay, that was like 11,004. So that will be between this 0 and 65,535. Okay, I said you will start with 0. If you are starting with 0, then you don't need to take the 36. You have to take it like a 35. Okay, total it will make it like a 65,536. Okay, but you have to start with the 0. Okay, if you are starting with 0, then the end last number will be like 65,535. Okay. So the total range of this port number will like 0 to 65,535, and this again divided into two types. Okay, one is what? Reserved or well-known port number. Okay, so that range is like 0 to 1023. Whatever the 23 you were able to see in that packet when we captured, so that is comes under this range only. These are the well-known port number that will be given to some particular protocols. Okay, after that we have random or unknown port numbers will be taken by any kind of ports, any kind of packets in the transport layer, okay, during the transmission. So that is mainly used by these two protocols, just like the TCP and the UDP protocol. Okay, after that we had sequence number. What is the sequence number size? What is the sequence number size? Sequence number size 32 bytes. Bits. Okay. So why this sequence number is important? Okay. This will help to rebuild the data at the destination end. For example, as I already said, the transport layer is going to segment the data. When it is getting the data from the upper layers, what it is going to do? It is going to break that whole data into some multiple segments. Okay. So once it is reaching the destination, how the destination device is going to understand this is the sequence that how I have to rebuild the data. Okay. For example, you have the data like data only. This is what at the sender end. So can I give it like 1, 2, 3, 4? If I give sequence number like this, does the data in the proper manner? No, it will like T A D A, TADA. Is it a proper data what I'm sending? No, right? So this is where the sequence number will help us. Okay. So once this data is sending from source to destination, we have this data. Okay. Once it is sending the data, it is going to give the sequence number. It is going to give this date D as a 1, A as a 2, T as a 3, and A as a 4 again. Once this D reaches to the destination device, okay, what is it's gonna do? It's gonna give the acknowledgement number like 1 plus 1. Now, what is this 1 plus 1 is? I got the first one, whatever the first segment you sent. Okay, I want second one. Second means what? 1 plus 1 is what? 2. I just want the second segment. Okay, this is what called acknowledgement number. Sequence number that will help us to forward the data and rebuild the data in a proper manner at the destination. Once it reaches the destination obviously it is going to send the acknowledgement in this form 1 plus 1. Okay, after this 1 plus 1 comes back to the source. Okay, then again it is going to send the second data packet, that is A, second data segment. Okay, again it will be sending it like 2 plus 1. I got your second segment. Please send me the third one. I'll be waiting for that one. Okay. So same thing will be there between the devices. Understood? So this is how the sequence number and acknowledgement number are co-related with each other. Okay. Based on this only, they are going to send and receive the data and even the acknowledgement also. Okay. Fifth packet will be gone if the data is there in the same. Then again, the sequence number will be changed. Different data stream will be gone. Okay. Next is header length. There we study it as a data offset. Okay, that is a 4-bit what is this now? In this field, we will get to know the size of the complete TCP header. Okay, here it will be mentioning like what exactly the size of this TCP header, only TCP header. Okay, nothing else. After that, we have reserved bits. That is, this field will be reserved here in this TCP header for the future use. That is 6 bits. Okay, already we used 3 bits. Okay, and only 3 are remaining. Okay, after that, the 6 flag we already talked about. One is the acknowledgement that will be exchanged between the devices every time. Okay, just to acknowledge whether the data is received or not. Okay, and then the synchronization, which will be used only during the connection establishment. After that, it will not be used. Next is what? Finish. If you want to end the connection or finish the or terminate the connection what you established, at that time this finish will be there. And the push flag, again, if you want to push any kind of message immediately, okay, at that time the push flag will be there. And the urgent flag is what? Whenever this urgent pointer, like this field is used for what? Just to set some priority on the specific data. If you are giving some priority to this particular data, okay, this is the data which is very important and that should be sent first. Okay, at that time the urgent pointer that will be mentioned in the urgent pointer, at that time the urgent flag will be high. So based on this urgent flag only, the device, they are going to know that yes, this is a VIP, very important packet, I can say, that should be sent first. Okay, at that time the urgent pointer will be high. And then if the network administrator want to reset the connection what it got established, at that time the reset flag will be high. Clear? So these are the 6 flags we have. Next we have window size. Windowing. Do you know what is windowing? What is this? It's your operating system. No. Window size. Okay, leave it. Sorry. Data size. Okay. So window size means what? This field is going to specify the flow control between the 2 network devices. Okay. So let's suppose like we have 2 devices again. Okay. And Ethernet, which is using fast Ethernet here in between these 2. Okay. And these PCs can able to send the data up to 1 Gbps. Okay. And this is also able to receive 1 Gbps. Okay. So what is the cable we are connected in between these 2? Fast Ethernet. What do you mean by fast Ethernet? What is the speed? 100 Mbps. 100 Mbps. Yes, this PC is able to send the data up to 1 Gbps. But what is the link we are connected between? That is only 100 Mbps. That means it can't send the same data speed. I mean, it can't send the data at the same speed. Okay. What that it will do? It's gonna buffer the extra packet. It's gonna buffer the extra packet. And these packets will be served as FIFO. First in, first out. Okay. So maintaining this flow control, I mean, whenever this link, which is really traffic full, okay, which is really busy to send the traffic, at that time, it is going to reduce the speed. Okay, these devices, they are going to reduce the speed by buffering the extra data. Okay, and if these devices, they are finding this particular link is totally free, at that time, again, they are going to increase the speed. Whatever this decreasing and increasing the speed is there, that is called as what? Windowing. Understood? So that will be given in the window size here. That is of 16-bit. Okay. Next is checksum value. This field specify the exact data rate towards received device. So this is also kind of what? This is used for what? Data integrity. Okay. So here we use three checksum methods. One is a parity bit. Okay. Second one is a CRC. Third one is a checksum itself. What do you mean parity? Here we have two types again. One is a odd parity and second one is a even parity. And CRC means what? Cyclic redundancy check. Okay. Last one is a checksum. So what are these three are? Okay, let's suppose like we have parity. Yes. So we have this data 1 0 1 1 1 0 0 1. Okay. So let's suppose like if it is using the odd parity. So what it will do? It will count the number of ones. If the number of ones are even, then it is going to give the parity bit as 0. If it is going to give the parity bit as 0. Okay. So how many numbers of ones do we have in this data? 1, 2, 3, 4, 5. So then what it should be? It should be 1. Okay. It will be adding an extra bit to this particular data. Okay. And once this data goes to the destination device, once it goes to the destination device is going to again calculate the checksum value. Okay. It finds that there is a parity bit as a 1. That means there should be the number of ones should be odd. Okay. Let's suppose like something happened during the transmission. It got changed. 1 1 0 1 0 1 1. Okay. 1 2 3 4 5 6. It's just an example. It got changed. Okay. But what is the extra bit? What we have? 1. According to this data, the parity bit should be 0 because the number of ones are like even there. Okay. But what we are having? 1. That means according to that parity bit, it should be having the number of ones as a odd. Okay. That means the destination device is going to understand that this is not the proper data what the source has sent. Something has happened to this data. Okay. So that's the reason it is not going to send any kind of acknowledgement for that. Destination device is not going to send any kind of acknowledgement to that particular data or segment to the source device. If the source device is not getting any acknowledgement from that destination device with that particular segment, then again it is going to retransmit the data. So this is where the checksum value is really important. Understood? So this CRC and this checksum value, they are having their own mathematical calculation. Okay, that you don't need to do anything. The systems will do by their own. Okay, again, just for example, I said you like why this checksum value is really important. Understood? Clear? Next, as I already said you, urgent pointer, this field is used for what? Set the priority on the specific data. Okay, so this was about the TCP header. Any question? Any question? Online? Online, any question? Okay, we'll finish this last one. I'm not going to explain much there because there's nothing in the UDP header. Okay, we have only 4 fields here. So this is 16 bits, this is 16 bits, this is 16, this is 16. Total it is making like 32, 32, 64 divided by 8, 8 bytes. 8 bytes is the size of that UDP header. So there will be having a 4 fields. One is again the source port number, destination port number, header length, and the checksum value. Same what I have explained in this TCP header, same they will be working as. Source port number, they will be between 0 to 65,535. Again, based on what protocol it is using, that will be given in the source port number and the destination port number. Okay. And header length, That's nothing but the UDP header length. After that, it will be having a header and the data checksum value. Clear? Yeah. No question, right? Sure. Okay. Okay, then we'll end it here today. Okay. Tomorrow we're gonna meet at the same time. Till then, everybody take care.